So today we want to write the partial fraction decomposition of one of these that we set up earlier yesterday. It is 5x squared minus x plus 27 over x cubed plus 9x. So what's our first step when we're writing a partial fraction decomposition? Factor the denominator, the bottom of the fraction. So we have an x in common, so an x squared plus 9. Can the x squared plus 9 be factored further? No. So we want to have an x in the denominator of one of our partial fractions and a x squared plus 9 in the denominator of the second one. So what goes in the numerator of the first? A, just some constant. And that was because it was linear, so we put a constant on top. The second one is quadratic, so we put bx plus c, which is a linear, on top. All right, so now we're ready to start getting rid of the denominators. Okay, we are getting rid of the denominators. That means that we're multiplying every single term by x cubed plus 9x, or x times x squared plus 9. And the denominator cancels here, the x goes away, and the x squared plus 9 cancels. So what are we left with? Well, 5x squared minus x plus 27 is now equal to what? A times that x squared plus 9, and yep. And is it okay if we put the x in the front? We're used to it there, right? Makes more sense. Now, slight problem, because yesterday we were very, very, very strategic about what numbers we chose to let x be. And we don't have a lot of options here. Okay, so let me show you another method that we can use. Let's distribute everything through to simplify this. So we will have an ax squared plus a 9a plus a bx squared plus a cx. So when I take the x times everybody, I'll get a bx squared and a cx. Okay, so far so good? Okay, now I'm going to gather some things up here. I want to take this ax squared and this bx squared and put them together. And I'm going to write these things in descending powers of x. So I'm going to put my cx next. And I'm going to put my constant at the end. So far so good? Okay. Good question. Why did I change these colors? Good. What are you noticing? Coefficients. Sorry, just getting crazy with my colors here. Okay. Exactly. We can use those coefficients to do some mathematical wizardry. Okay? Because if a plus b is the coefficient in front of x squared, and 5 is the coefficient in front of x squared, what do you think 5 has to be equal to? A plus b. And if -1 is the coefficient in front of x, what do you think c has to be? And if 27 is the constant, what does that have to be equal to? So A will be 27 divided by 9, which is 3. B will be, if A is 3, B has to be 2. And we know C is a negative 1. Yeah, it's kind of fun, right? I do too. It just kind of falls in your lap, doesn't it? Okay, so now we can rewrite this as 3 over x and 2x minus 1 over x squared plus 9. Make sense? Okay, thank you. All right, next example. Questions on this one first? Yes, absolutely. Give you a little time to write. Okay, to get the C, we said we have a C is the only coefficient in front of x, and the understood 1 is the coefficient, negative 1 is the coefficient in front of x, so they have to be the same, have to match up. Okay. All right, so here comes the next one. Everybody ready? Okay, here we go. So now we're writing the partial fraction decomposition of 6x cubed plus 16x over the quantity x squared plus 3 squared. All right, denominator's already in factored form, right? Okay, so to make this work, we need to gather up everything. So we need an x squared plus 3 squared and an x squared plus 3. Okay? It's a process in which you're making sure that you have all parts of it. Okay? So what are the factors of, well, first of all, when we had something like so we need 2 of them and we need 1 of them. We always take what the squared term and also the original. So if it was a something over x squared, right, and we're trying to break it down into its individual parts, we would need an x squared and an x. Okay? And if it was an x minus 3 squared, we would need an x minus 3 squared and an x minus 3. Okay? So what are we putting on top of our x squared minus 3, or x squared plus 3 quantity squared? It's quadratic, right? So what goes up there? X plus b. How about the second one? Cx plus d. It's also quadratic. Okay. So far so good? All right, so if we multiply everybody by that denominator, this one's canceling. Yep, that's also all gone. Everything's gone. And x squared plus 3 squared, the whole thing doesn't cancel, just one of them, right? Exactly. Okay, making sense? Some people can quickly make that jump, right? And say this denominator's going away, And this one already had 2, so it's going away, but this one only had 1, so I need to multiply it by what was over here. But others need to see the canceling every time. When you get to that point where you don't need to cancel anymore, you can skip that part. Does that make sense? Okay. All right, so 6x cubed plus 16x, the denominator is now gone, and then we're going to have an ax plus b and cx plus d times that x squared plus 3 that's still left. Because we've taken care of both of them. They're both gone. Question. So we're going to FOIL it. Okay. So when we FOIL this, we'll have a cx times an x squared, a cx times a 3, a d times an x squared, and a d times 3. Okay? Because there's no good numbers to try, were there? There's nothing that's going to make this parentheses disappear that we can plug in. Okay, there's solutions. It's just that we can't use our trick from yesterday to pick really good numbers. Okay? All right, so let's gather things up. We have 6 in front of the x cubed, right? So what does it have to be equal to? C. So 6 has to be C. That was the only x cubed we had. Okay? Do we have any x squareds? No. So 0x squareds have to be equal to d x squareds. Okay? We have a 16x. Okay? So 16 has to be equal to, yep, and we want to take the x's out, so we just want the a plus 3c. And do we have any constants? Nope. So since there's 0 here, that 0 has to be equal to our constants, which are the b and the 3d, right? Everyone see why? There's no constant on the left side. All right, so we know that C is 3, C is 6, and D is 0. So we can plug those in. If C is 6, then 16 equals A plus 3 times 6. So what does A have to be? A is -2. And if D is 0, then 0 has to be equal to B plus 3 times 0. So B has to be 0. Okay? So now we just rewrite. This becomes -2x plus 0 over the x squared plus 3 squared plus our c we said was 6, so 6x plus 0 over x squared plus 3. There it is. Clever. Magical. And so if we found a common denominator here and simplified, we should get this back. Okay? Because what do they have for a common denominator? x squared plus 3 squared, right? This one's missing the x squared plus 3. So if we took this times x squared plus 3, we'd get 6x cubed, right? Plus 18x. 18x minus 2x is 16x. Now do you see why we have to have one of each? Okay, that helps us get it. All right, next one. Not difference of squares, but difference of cubes. All right, so someone around here has been using the SOAP acronym. And the SOAP acronym helps you remember the signs of how this is going to factor. And before we worry about the signs, let's think about what this is going to be. This is a difference of cubes, right? So it's going to factor into a binomial times a trinomial. And the SOAP acronym helps you remember that you use the same sign in the first parentheses. So since it was a -1, we're going to use a minus there. Then we use the opposite sign next, which is a positive or a plus. And then the last one is always positive. Okay, so we've got our signs out of the way. What goes in the first spot of the binomial? X, the cube root of this guy, right? What goes in the second spot of the binomial? 1, the cube root of 1. What goes in this spot of the trinomial? The first one squared, so x squared. What goes in the middle? X, right? The product of these two. And what goes into our last? The 1 squared, which is 1. If you've forgotten the sum or difference of cubes, that's how we do them. Okay? All right, so we need an x minus 1, and we need an x squared plus x plus 1 as the denominators of our two partial fractions. What goes in the first numerator? A, because this is linear, we just need a constant. What goes in the second numerator? Bx plus c. So if you can take the shortcut, if we multiply everybody by x cubed minus 1, that's going to eliminate the denominator here, right? So we'll have 5x squared plus 4x plus 6 equals, what does a have to be multiplied by? The trinomial, right? The one that's under the other fraction. And what does the bx plus c have to be multiplied by? The x minus 1, the denominator of the other partial fraction. Okay, now, could our shortcut work here? are choosing a very special number to work smarter, not harder. Maybe. What would that number be? 1. So let's try that. Okay, it's going to help us reduce the problem and make it easier. So everyone see how if we make this be a 1, we get a 0 here, and that eliminates a lot of stuff. Okay, so let's let x be 1 like we did yesterday. Then we'll have 5 times 1 squared plus 4 times 1 plus 6 equals a times 1 squared plus 1 plus 1 plus bx plus c times 0, right? That was our whole goal of choosing 1 to make the b and c go away. So far, so good? That would be a b times 1. I just rewrote it quickly and not thinking. So b times 1 plus c. So b plus c is going to be multiplied by 0. Okay? And so we'll end up with 15 equals 3a, because that's gone. So what's a? Okay? So that helped. We got 1/3 of our way done, right? We still have to find b and c. Now, is there a good number to plug in here to make things go away? Maybe. We could try 0. -1 won't work. Kind of a mess, isn't it? We could try 0. 0 might be helpful, right? We'll still have a 1. We already know what a is, though, right? Okay, so let's plug in 0. You can use a blend of what I taught you today and what you did yesterday. Okay, so we're still choosing some strategic values. So if x is 0, we've got 5 times 0 squared plus 4 times 0 plus 6, so 6. And then a is going to be times 0 squared plus 0 plus 1. So we'll have an a 1a. And b times 0 is going to get us a 0. But we'll have a c times the 0 minus 1. So a -1. So that's not looking bad. Because if a is 5, right, then 6 equals 5 minus c. And so we bring the 5 over, and if 1 is a -c, then c has to be. So we've got 2 of them. Okay. And we could try that and plug all those things in. The problem is we'll still have x's in there. We could do that. We could do x equals -1, or we could do the hybrid of what we were doing earlier, right? Because we already know what c and a are, right? So we only have to worry about the coefficient in front of b, right? Okay. So let's do what we were doing earlier today and say, let's think about what this is going to be FOILed out. We would have a 5x squared plus a 4x plus 6 equals ax squared plus ax plus 1 plus bx squared minus bx plus cx minus c. Sorry, did I do something wrong? Ax squared, yes, this should be an a, not a 1. A is being distributed by everybody. Thank you for catching that. Okay, so we know A, we know C. The only one we're interested in is B. So here's one with B in it, right? We have an ax squared and a bx squared. So a plus b have to be equal to 5. And we know a already is 5. So what's b? Yep. So you can get creative in how you do these, work with these. Okay, so what is our new partial fraction going to look like? Well, a was 5, so we'll have a 5 over the x minus 1. And b is 0, but c is a negative 1. And that'll be over the x squared plus x plus 1. They're quite the amazing problems, aren't they? Questions on any of this? Did I lose anyone anywhere? All right, assignment is on 7-4, bold and underline. Yeah.